This is a quick video going over the two different types of hypotheses. So up until this point, we've really focused on the research hypothesis. And a research hypothesis is basically the type of hypothesis that you learned about in every science class you've ever taken. It's an educated guess. It's a short prediction. And in this class, we've talked about it as in these terms. It's a short statement about the predicted outcome of a study. So here we have over here in blue this study that we've talked about for a few videos now, looking at the relationship between noise and memory. And we have some data here. Here's how many things people remember in noise. Here's how many things people remember with no noise. So the way that we might write a research hypothesis for this study is to say very simply, noise affects memory. Right, and that meets the criteria that I've specified, which is in a research hypothesis, you want to talk about both variables. So we're talking about our independent variable here with noise. We're talking about our dependent variable here with memory. And I've written it in the form of a statement. So noise affects memory. Moving forward, there's another type of hypothesis that is important, and that is what we refer to as a statistical hypothesis. And there's actually two of them. So the first statistical hypothesis is something that we call a null hypothesis, and the other statistical hypothesis is the alternative. So I've written down here a few different ways that we can state the null and the alternative hypothesis. But let me just start with this idea here of this word null. So if I ask you, what does the word null mean? Think about that term null. What does that word mean? Hopefully some of you are able to think about that statement null and void. That's a good way of thinking about the word null. Null basically means empty, missing, zero. And in fact, that's really what the heart of the null hypothesis is all about. So the null hypothesis, in terms of symbols, we write this as H0. All right, so the null hypothesis is H0. And there's really three different ways of stating the null hypothesis. And these ways are interchangeable. So all three of these ways are basically saying exactly the same thing, just using different language. So one way of phrasing the null hypothesis is to say there is no treatment effect. All right, so let's think about what that means in terms of our study here. So we're looking at this relationship between noise and memory. If we say there's no treatment effect, what are we really saying? What we're really saying is that we don't think noise is going to have an effect on memory. When we say there's no treatment effect, we're saying we don't think noise affects memory. All right, so one way of saying it is there's no treatment effect. So another way of saying it is the means are equal. Now let's think about what that means. If there is, in fact, no relationship between noise and memory, then we would expect that the mean number of items remembered in noise would be the same as the mean number of items remembered in no noise. So if there's no treatment effect, we would expect the means to be equal. And then this last way of saying it, this is the Greek letter M. It's pronounced mu, as in M-U. It's pronounced mu. And this says mu1 equals mu2. Basically what that's saying is the mean of the first group is equal to the mean of the second group. And now we have two groups here, so we can say mu1 is mu2. Mu1 equals mu2. If we had a third group, then we would say mu1 equals mu2 equals mu3. All right, but again, all of these things, these three ways of saying it are all saying exactly the same thing. There is nothing going on. Notice we don't actually talk about noise and memory in here. And that's the expectation that I'm going to be using for this class. When I ask you to write a null hypothesis, I don't want to see your actual variable names. You are going to write them exactly like I've written them here. This is literally something that you memorize. There is no treatment effect. the means are equal, mu1 equals mu2. Moving over to the alternative hypothesis, symbolically we're going to call this H1 compared to H0 over here. We're going to call this H1, and the alternative hypothesis says exactly the opposite of the null hypothesis. There is a treatment effect, the means are not equal, mu1 does not equal mu2. And again, all three of these things are saying there is something going on. All right, there is something going on. All three of these are saying exactly the same thing. And again, thinking about this in terms of our study, what we mean here is that noise does affect memory. But again, we're not going to mention the variables in here. We're just going to memorize these three different ways of saying it. All right, so some of you are probably wondering, well, why do we have these two hypotheses? They contradict one another. And why would you even make this null hypothesis at all in the first place? What would be the point of doing research just to make a prediction that you're not going to find anything? Well, it turns out that when we do research, we're going to make all three of these predictions. We're going to make a research hypothesis. This is really what guides the research to begin with. And then we're going to make these null and alternative hypotheses. These are what guide our statistical analysis. And it actually turns out the null hypothesis, even though it's the one that seems out of place, statistically is going to be the most important one moving forward. And this is the one that we're going to be using to evaluate our inferential statistic.